Hello, year 8. Last lesson of the week. We are doing about group 1, so it is a good idea to have your periodic table ready, because this first group here is what we will be looking at. So let's go into the thing. We will be doing that. We will go through the PowerPoint, you'll watch a video, and then you'll do that worksheet there. So let's get started. So, hopefully, we won't be able to. You won't be able to really do this, as we haven't been able to do some of the stuff in lessons that we would have normally done. So, as long as you know where the Group 1 metals are, you can name them, then that's perfect. Here are the lesson objectives. So pause it to read them, and then we can continue. Now, quick true or false. Pause it, have a little go of these, and then unpause it when you think you've got the answers. Right, this first one. This is false. There are about 100, just over 100, around about 100, sorry. You can check that by going onto your periodic table and seeing the one with the highest proton number. The number of protons will tell you what number element it is. The second one is true. All elements are listed on the periodic table. So this is false. Remember, elements contain only one atom. Elements contain one type of atom. This description here was for a compound. This is false. Most elements are metals. And this is also false. Most elements are solids at room temperature. Okay. So, group 1, also known as the alkali metals. The elements in group 1 of the periodic table are called alkali metals. They include lithium, sodium, potassium. Now, we should have already found the other ones that are in this group. So just keep going down that list. That is where the group 1 metals are. Now, hopefully we remember what universal indicator does. If we don't, I'm going to give you a quick recap. So the universal indicator can tell you the pH of something. Now, for some reason, the formatting's gone a bit weird. The 7, that could be crossed out. It should say 7. pH is a measure of how acidic, neutral, or alkaline something is. Now, water is the only really true neutral thing, and then depending on what you've got, depends on how acidic something is. For example, stomach acid. The acid in your stomach is about pH 1. Some kitchen cleaners will be about pH 14. Maybe an orange or a lemon will be about maybe pH 4 or 3, somewhere around here. Okay, so they're a little bit acidic. If you ever get those really sour sweets, the sour sweets are acidic. Okay, if something's acidic, it gives it kind of a sour taste. Now, the reason why we call these the alkali metals, and I'm going to do the equation on the next page, is because when you react them with water, they create the compound that is left is alkaline. Now, let's do an example. Let's say I have lithium plus water. It will react to make lithium hydroxide plus hydrogen. Okay. So this is the general word equation. Maybe if I had sodium instead plus water, it should make sodium hydroxide. Plus hydrogen. Now, this is the thing that is alkali, this compound. The hydroxide is the alkali. So if I added universal indicator to this, it would turn blue or purple. So if I had rubidium instead, I would literally just write rubidium here. And this is why we arrange these all in the same group, because they react very, very similarly to water. So I'd like you to now write the word equation for potassium and water. So pause it, write the word equation for potassium plus water, and then unpause it. Okay, hopefully you've done that, and you should have got it is potassium hydroxide plus hydrogen. So it's relatively straightforward. All the word equations are very, very similar. Now, something that we have to know. Alkali metals have low melting and boiling points, okay? But you need to know the trend. So lithium, which is at the top of the group, has the highest melting point. And then cesium, which is at the bottom of the group, has a lower melting point. Well, it's at the bottom of these ones that we've got here. Francium is below that, but francium is radioactive and very unstable, and you can't really have any francium because it decays too quickly. But we learn more about that in GCSE. So as you go down the group, the melting point decreases. Okay. So I've just described the trend there. As you go down the group, the melting point decreases because it starts at about 180, then it goes to about 100, then about 65, etc. Now, another property that we need to think about, or we need to understand, is density. Now, for now, you don't have to remember this stuff, but if you are presented with this information, like this table here, you would have to describe the trend. So you wouldn't have to memorize this just yet, but you would have to describe what is happening. So remember, the density of substance is how compact the particles are, which means that if you had the same amount of something, say I had 1 cubic centimeter of each one of these elements, the higher the density it is, the larger the mass would be. So it's kind of a measure of how much mass does it have for its size. Now, alkali metals have very low densities compared to most other metals because the density of water is about 1, and if you have a density of lower than 1, you float on water, and it's quite unusual for a metal to float on water. Okay, but lithium, sodium, and potassium do float on water. That is why when you watch the video in a bit, you'll see when you chuck them in water and they start to react, they float around on the surface. So, I'd like you to describe a general trend that happens as you go down the group. You might even mention something that does not fit the pattern. So pause it, have a go. Okay, hopefully you've done that. And what you should have said is as you go down the group, the density increases. And you might have said apart from potassium. Okay, so as you go down the group, so let me write that out then. As you go down the group, the density increases. Okay. You could then also say apart from potassium, because that is what we call an anomaly. It is an outlier. An anomaly means it doesn't fit the general pattern, because generally 4 out of 5 of them fit that pattern. Now, today is actually a really quick lesson because we can't do the experiment stuff. But what I want you to do is I want you to watch this top video here, okay? This video here. It's a person who's got the elements in front of him and he does reactions with them. Then I'd like you to do the worksheet. Optionally, after you've watched this first video, you can watch the Brainiac version, which is this one at the bottom. Okay, it's less realistic. It's more dramatized to make it more fun, right? But you absolutely need to watch this first video. You can watch the second one if you want to. Then I'd like you to do the worksheet. So let me discard this. So this worksheet here. Right, when you are watching the video, now you don't have to write on this, but you can write this down, right? You can say, you can copy this table down. I'd like you to do the observation. So as he puts the lithium, sodium, and potassium into the water, what do you see? Okay, and what do you hear? Then you've got a few questions, and just write the question number. Okay, don't copy it out. So question 1, are they metals or non-metals? Why? Use the periodic table. Okay, and then so do questions 1 to 5, and then you can submit your answers to me, and then you are done for today.